Thank you so much. All right. So we are going to undo this data structure. So from today, we work on some in arrays, move to HashMaps, linked lists, tags, queues, and binary search tree. So from yesterday, we talked about time complexity, and we spoke about the different time complexity we have of 1, of n, of log n, of n log n, n of n square, of n factorial, of as the case may be. So I did a basic data structure here, a basic table to show the data structures and the time complexity to take to access. So for instance, arrays. Give me 1 minute, please. Let me turn on this presenting and start again. Okay. So for instance, when we have arrays as the data structure, let me open the whiteboarding again and open Google Docs. Google Docs. Google Docs. Sorry about that. All right, great. Okay, present again. Okay, you should be able to see my screen right now. All right, we are going to get into time to work on this. Basically, all the classes we had yesterday, this is just like an overview of it. So let's say we have an array, maybe int of integers. Let's call this array RR equals to how we implement them: 10, 6, 8, 9, 14, and 50. So this table here, you can use it to show for an array to access any element in the array. As far as you know the index, the time complexity of that is O of 1. So if you want to find the 0th index, that will be 10. It will happen in constant time. As fast as the fastest you could get. If you want to access the 5th element, or the element at the 5th index, 0, 1, 2, 3, 4, 5, that would be 50. So it's O of 1. It doesn't loop through this, it just gets it in linear time. But say you want to search for an element in array, you are going to, the time complexity you have is O of n. Now, all these letters, marked in red is the worst case scenario, right? So we are looking at, okay, what's the worst case of access? So O of 1, O of 1, O of n, O of n. When you want to search for a number, say you have this array and you want to search for number 14, you have to go through all the array to determine where 14 is, and you find it if it's in the array or not. And if you want to search for number 10, you have to look through the array. And remember what we said yesterday, right? That one of the 3 big rules of big O notation. Number 1 is that you have to always search for the worst case scenario. You are talking about the worst case scenario because you can't predefine the input you are going to receive from the user. So 10 is at the first index, but we are not going to be assured that 10 will be at the first index forever. So the worst case scenario, to search through it, you are going to get O of n, worst case O of n. I will explain why we have worst case and the normal case. Same thing if you want to insert into an array. If you want to insert into an array, you have to look through every element in an array, because I think different languages in Java, I think there's something like arrays.copy. Right, let's try to open a Java program. New project. Java FX, Java demo. All right, name demo. Let's get that started. Give me a minute. Let me do this. Okay. Whatever this is. command main. Let me see, I want to create a new. Okay, this is just Kotlin for the minutes. Give me a minute, please. All right, let me explain this and ensure IntelliJ setup. Sorry about that. So if you have a arrays.copy function, arrays.copy function, this is exactly how it works. It creates a new array of the size of the array you want to copy, right? So if it's 10, if it's 6, this is the size 1, 2, 3, 4, 5, 6. It's array 2. So you make this 6. So you are telling the indexes. So it's creating a new array of this. Then it will now loop. So for your normal loop, int I is equals to 0, I is less than or equal to 1, I plus plus, ARR I, ARR2I is equals to ARR I. So this is basically the operation, that's the inbuilt operation in that. So you are actually looping through the array when you do this arrays.copy. So if you are inserting, because an array intrinsically there's no standard record for the first and the last index. You can want to add an element at the last index, it will have to copy the whole array. And if you want to add an array like this, it will copy the whole array, but instead of int 6, it will be int whatever the size is plus 1. You get. So the same thing if you want to delete an element, you can't. If you delete 9 from the array, it will become blank. So you can't have a null value in this array because it's an array of ints. It's not an array of nullable ints. It's an array of ints. So if you have to delete this, you have to create an array of this same size, look through it and get that done. Then we have HasMaps. So we are going to look at just these two for today, right? So we have HasMaps. There's no access time for HasMap because HasMaps don't have indexes. So just give me a minute, please. I need to get this thing done on IntelliJ. Sorry about that. Project. All right, let me present now my entire screen. All right, I need to go through this again and know how to create my new Java projects. So, farm, new project, and make sure Java is selected language. Java, yeah, and we're good to go. All right, so we have this. So let me show you something about that. So I'm creating a Java class. I want to call this program. Main function. So let's say we have arrays dot copy. Of this, let's have this function. So let's try to find the Java docs in this. So this is the Java docs. So it has copy of original this, and if you click on this, we have system.array.copy. Let's go here too. Anyways, here it's showing that it's creating a new copy of the array. So if you look at the initial Java docs, basically it's creating a new copy of the array. And that's one of the challenge we have most times when we are building data structures and array, data structure and algorithm problem, because sometimes we say, why can't we use inbuilt function? If you really study the inbuilt function, you find out the time complexity of the inbuilt function. If it's going to create a new array and then the time complexity is going to be as the length of the array. So let's keep that aside for the knowledge. So let me show a case of this program, is that where we use arrays and HasMap to solve a specific problem. Say we have this problem, we defined it yesterday, we are supposed to solve it. Given two arrays, create a function that lets the user know whether these two arrays contain the same elements. So let me increase this. So this is the example, array this and array this. We have to return true or false to show if they contain, even if it's one unique element. Let's show it. So we have X here and we have X here, right? So this is supposed to return true because we have common X in both of them. So how do we go about solving this problem? Now, we first, basically, if they ask you this kind of question in the interview, it's like a pretty straightforward question, but most times you want to ask, what are the constraints? Would I have an array that is empty for any of them? You want to ask that because you want to catch some of those edge cases. We'll have array that is empty. Will the arrays be of the same sizes? If not, how do I go about it? So say, for instance, we have this, right? We want to copy this into our IntelliJ code. So let me take this and come to IntelliJ. Let's see how we're going to solve this. Here's the question. Given two arrays, create a function. Can you see the screen clearly? Can everyone see the screen clearly?
It's clearer now.
Okay. All right. Let me minimize this so that I have everything on screen. So we have this array and this array. Now we are using Java to solve this. So we are going to create a function. Let's say maybe the function should also be a static function, static Boolean. What should we call the function? Given two arrays, create a function that lets know whether these two arrays contain the same element. Contains same element. Now we are going to send in two arrays. Well, we are not dealing with integer arrays. Here we are dealing with character arrays. So we are going to have array 1 and array 2. So to ensure this code runs, let's say we return false. So considering the first edge case, we are going to ask what will happen if any of the array doesn't have any elements. That's if the size of this array right now is 0 or this is 0. We know that if any of the array is empty, what do you expect to do? Because you might think, okay, let me return. Do I need to do any computation? But you have to ask the interviewer directly. That's when you are doing a live coding section. How about a situation where any of this array doesn't have any element? An array like this, maybe array 3, something like this, right? What will happen if you get this case? Or what will also happen if you get array 4 is equals to null? Because all this can happen, right? So how would you handle that? So the interviewer will tell you what you will return. So for instance, if we have an empty array, we know they don't contain the same elements, we are going to return false. If any of them is null, we are going to return false true because we don't want to do any kind of operation on those. So now we've gotten these two edge cases. How do we capture it in our code? We just come and write a simple if statement. If AR1 is equal to null or ARY2 is equals to null, return false. So we just captured this edge case. Now I know I wrote this thing, this one before this, so I'm supposed to capture this edge case before this, but then if, for instance, you are trying to capture this edge case before this, you are going to get an error in your code. Let me show you why. So if we have if ar dot length is less than or equal to 0, you can't have an array with length is less than or equal to 0. So let's use equal to 0, or ary2 dot length is equals to 0, return false. So why is this if statement? If statement can be collapsed, collapse if statement. All right, I don't want to collapse that. Anyways, so we have this function here. So let me call this contain same element function. So I want to declare two arrays inside this and call this function and show you why it will be best to call this before this. So let's say char ary1 equals to new char s4. Okay, how do you declare arrays in? Just do this. Sorry, ar1 0 is equals to, let's see, a equals to abc, a b c d, and this is x. So let me copy this and duplicate it here. R2, this is 3. So we have x, y, z. So let's say we have these two. Right, let's say we have these two. In the case we have a third array, char ary3, and we have this. Then we call the contains function, contains same element, let's say ary3, comma ar. Oh, we are already getting, might not has been initialized. Anyways, let's say this equals to, so let's system.out.print. So we want to print this out. And we have ary is equals to 3, so we are passing it as an element of this array, right? So let's run this and see what will come about in the code. So we are having an exception in the thread. Okay, somebody wants to join the meeting. Sorry, let me. Okay, so we are having an exception in the thread. Index 4 out of bound for length. Oh, sorry, we don't have the fourth element. This is 5. This is 0, 1, 1, 2, 3. Sorry, let's run that again. So now we're having a different exception in main, null pointer exception. So if we go here, this is where the exception is being called 30. So as a programmer, you need to catch these edge cases. Now, sometimes, I mean, in Google and others, when they are calling for these interviews, you are not going to be coding it here. You are going to write it basically on Google Docs, something like these documents. They will give you the assignment here. You're going to write it here, and it should be runnable. So, I mean, if we do this, it shows that the code is not runnable. And why? Because we are trying to get a length of a null value. This array we are passing here is null. So we are trying to get it length. Questions. We want to know which edge cases to catch so that our code will run. So first of all, we have to capture null cases. So if I move this downwards and run the code, so it returns false because this code now ran. So the code it's working fine now. It's not crashing, right? But it's not doing what we want it to do right now. So at this point, when you're capturing edge cases, you have to capture for null cases. Then you also have to capture for cases where the length is equals to 0, right? So that being said, let's go into the major implementation of the code right now. So we want to pass in these two arrays. So let's ignore array 3, pass array 2. So how do we do this? Basically, the first way to do it, the first ever way, we have to say for int I is equals to 0, I is less than ARY dot length, I plus plus. Then we do another for loop for int j is equals to 0, j is less than ARY2 dot length, j plus plus, right? If sorry, if AR1 I is equals to ARY2 j, return true. And what did we do here? So we are looking through the first array, but for each element of the first array, we are looking through the next one to see. Sorry, I think we'll find the best way to admit people into the calls. Sorry about that. So we are looking through the first array. Then for each element of the first array, we are looking through the second one to find out if the element at this index is equals to this. So how will this code function with this our for loop? So let me take this to Google Docs so that I can explain it further. So we are here at Google Docs and we have this loop here. Let's make this normal text, and increase it. So we are going to do it like this. So for A, when the first array we are passing is this, right? So for A, we test each element in I. So we test is X equals to A, no. Then it will go to Y. Is Y equals to A, no. Is Z equals to A, no. Then it will go to B. Is B equals to X, no. B equals to Y, no. B equals to Z, no. Goes to C. Do the same thing. D, do the same thing. Then you get to X and check is X equals to X. So when that is true, it returns true. So that's basically how this loop works. This very loop we have here. So let's pass in the right value. We are not passing array 3 again. We are passing array 2. And let's run this and see what we get. We get true. Yeah, because we have X here and X is also here. So I mean, this is like the base solution to it. We have not optimized anything, and it's just like that. But according to yesterday's lesson, who can tell me what the time complexity of this function is? Time complexity of this? Anyone?
I think that'll be O(n) squared.
Thank you. Exactly. O(n) squared, because we are having double loops. And like what we said yesterday, once we start getting to O(n) squared, we know that our code is poorly optimized. So looking at this, how can we make it more optimized? Now, if you're solving this kind of situation because of time, you have to give them a non-optimized solution first, then you go to the optimized one, right? Try to solve the problem before you talk about optimization. So this is going to be O(n) squared. O(n) squared. That is very, very bad. Like we shouldn't be striving for this in any array question because it's so poor. So how then do we, like someone will say, how then do we scale this to make it more of, maybe we could get O(n), because it's an array, you have to look through every element at least once. How can we get, how can we get O(n), O(n) at least, or maybe O(2n) or something? Looking through this array, how can we solve that? That will take us to our next data structure, HasMaps. Now, the reason why we have these data structures is so that we can look through it and say, okay, how can we use each of these to make our code more optimized? Because we are searching through array, and array is O of n. Maybe actually in this case, it's maybe not O of n, but O of a times b. Sorry, got that wrong. It's right, because it's O of n squares. O of a times b is also in the category of O of n squared, but our second rule says that our third rule says that each input should have their own representative. So it's A of a times b, which is actually equal to O of n squared, right? This is equal to this. So it runs at the same time. They are all in the same bracket. It's a terrible solution, right? So how can we make it such that we can even have O of 2n or something like O of a plus b, something like this. So yeah, we are going to look at HasMaps, because we see searching through an array is going to take O of n, but looking through an HasMap is going to be O of 1. I will get to this worst case scenario shortly, and I will explain why we could get this in HasMaps, because HasMaps is a solution to many things, because it helps the code run faster. So how do we get this? So in that case, we have to convert either one of these two arrays to an HasMap, right? So we show you how to use an HasMap in this code. So we have this solution. So let me leave that solution, because I don't want to spoil anything there. And create another static function, contains same element, optimized, right? So we still have our initial constraints, duplicated code fragments. Nope. I mean, intelligence to intelligence. They are telling us this is duplicated here and is duplicated here, so we should extract it to a different function, which is very good in clean architecture, but that's not what we're trying to achieve here, so I'll leave that. So we will leave this out of the equation. So we want to have a HasMap. So how do we convert an array to an HasMap? So I'll just have to create an HasMap. This is Java method of creating an HasMap. Character. Let's call this, what should we call it? HSH equals to new HasMap. Character. Now, this is how an HasMap works. If we go to our Google Docs, yeah. So an HasMap works this way. An array, you have maybe 0, 1, 2, 3, 4. So you can have the elements commas. I really don't want to be increasing font in everyone. So you can have the first element as A, B, C, E, E. So an array, you have indexes. So you can skip from 0 to 4. So this is how an array works, right? But an HasMap works differently. In this case, an HasMap could have an HasMap doesn't have to go through index. It's not sequential or anything. So it's converting the index to a kind of associative array. So we are going to say A points to A, B points to B, C points to C, D points to D, and E points to E. So an HasMap, you can have any kind of input as the key. It's like a key value pair. Same thing with an array, but an array, since it's one dimension, the keys are predefined. You don't define the keys in an array. They are already predefined and given to you based on the size of an array. But in an HasMap, you can predefine the keys, and that's where you could have the time complexity of searching equal to the time complexity of access in this place. So let's go into code. Much talk, let's go into code. So I'm going to look through this array. Let me copy this code here. I'm going to look through this array and do this. For this equals to this equals to this, we are looking through the first array. We are now going to say is hsh dot put. character ARYI, value ARYI, this. So what does this do? Copy it out so that I can explain it in Google Docs. So what does this do, this function? So what does this do? So it loops through this very array and does exactly what we have here, except this case we're having X and X. So instead of 0, 1, 2, 3, 4, we're having A, B, C, D, X as the keys and putting them A with B, is B, C, D, D, X is X. And because this is looping through it once, we are going to have O, the time complexity as O of A. So we've looked through it once. Then we come over to the next part, which is we want to compare this element with every element in the hash map, right? So now I'm going to have another loop. Let me copy this, right? And put it here. So in this case, I want to loop through this array. So if I'm looping through this array, I will say if ARY2 A. Okay, let me do this. Let me create a character. Temp character. Temp is equals to ARY2 J, so that the code will be readable. So we are now going to have if HSH dot contains key. Now look at this dot contains key, right? We'll now put temp return true. Otherwise return false. Now we are putting return false so that if once it gets through this, it just returns true and the function returns what it is. You don't have to look through again. So let's carry this, call that function instead, right? And let's run this. So it returns true. Now this, like we say, this is a more optimized solution to this. Now let me copy everything that's inside here, and then of course we'll ask of the time complexity. So this. So who can tell me what is the time complexity of this current function now, the way we have it here? What is the time complexity? Anybody? Okay, Anthony, you raised your hand. Sorry, I was not. A lot of people raised their hands. Anthony?
Okay. My question was for the previous solution. I wanted to know.
Sorry. Yeah.
How can you get that specific character that matches that is in both arrays?
Okay, this solution. Oh, you're asking how is this solution working?
No, how can you now get the character or the value that is common in the two? How can you access it? How can you print it?
Okay, so sorry, I might not be getting you. We have contain same element here and we have contain same element optimize. Are you asking anyone pertaining to any of the methods?
The first one.
Okay, the first one. So you're asking how can we get the characters that are same?
Yeah.
That are contained in both arrays. Okay, now look at this question. The question is given two arrays, create a function that lets the user know whether these two arrays contain the same elements. Now the question could be phrased differently, like contain at least one element. We are not checking if all the elements in A are in B. That's a different solution entirely. This is just like an example solution. Check if they contain at least one element that's same. So in this case, they contain X. Say, for instance, in this case, we change it to a U and we put this here. So let's see if we get the right results. Because now, so it's false. So how does this code work? we are looping through the first array, which is this. Then for each of these, we are looping through this to check if it's equal. So for A is for the first element, which is A, we are going to check is A equals to X in this code. If A is equals to X, if A is equals to X, return true, but A is not equals to X. So this if statement is not going to run. It will go to the next loop, which is if A is equals to Y. If A equals to Y did not work, go the same thing to if A is equals to Z. Then once it's done with Z, which is where's that? Which is for array 2, right? Then it will now go to when I is equals to 1. And when I is equals to 1 is B. So for I is equals to 1, is going to test for where J is equals to 0 and J is equals to 0 will now be X. So it will text so X equals to B, no. Is Y equals to B, no. Is Z equals to B, no. Then it's going to increment I to 3. Then it will check for C. So X equals to C, Y is equals to C, Z equals to C, no. Check for D, same thing. Check for U, same thing. So in this way, we can find, I mean, assuming we didn't have this as U, we have this as X. Maybe let's do this, right? So that you will see how this works. Let's do this. This will help it. Else. So we want to print out system.out.println. Let's say ARY plus is equal to plus J. So I want to put this here to is not equal. Is not equal to this. So let's run this and you see how the code works shortly. So taking time. Okay. In this case, we pass ARY to first. So let's change it. Let's change the other functions we are passing. So this is it. So like I said, it's going to test. A is not equal to X. A is not equal to Y. A is not equal to Z. Then after it's done, can you see this input clearly? Let me zoom this out. A is not equal to X, A equals not to Y, A is not equal to Z. Then it will skip from A to B. B is not equal to X, B is not equal to Y, B is not equal to Z. Then it will do for C. C is not equal to X, Y, Z. Do for D. D is not equal to X, D is not equal to Y, D equals not, it's not equal to Z. Then when it comes to X, it will text is X equals to this, X equals to this, then it will stop. It's not going to text if X is equals to Y or Z. I don't know if you get the concept now, Anthony.
Yeah.
Okay, so that's how the first array works. It's working, but it's poorly optimized. Very, very poorly optimized. So I just printed this out. That's how the code works, and this just stepped out in that, so it returns true. So we go to the second element now. So I'm just going to discuss how this works. It works exactly like the first one, right? Works exactly like the first one, but with a different caveat. So let's take this. I mean, I want this to, I want it here. System.out.println temp is equal to J, else system.out.println temp is not equals to J. So let's change the name of the function, the optimized one, and call that instead. So I mean, X is equals to X and Y is X equals to X. Which array are we putting here? Okay. That was so sorry. Let's run this again. Okay. The way HasMap works, right? It's quite tricky from the way array works. An HasMap, since they are not indexed, the keys are not indexed. Coming here, we talked about the indexing of HashMap. HashMap is not following a sequential index. So the first one could be the first index could be Z, the second index could be B or whatever. HashMap doesn't follow any structure of that. When you are calling HashMap, it can't even tell, you are not going to get the index sequentially. You are not expecting that at all. So the behavior might be different. So we having A is equal to A, B is equal to B, C is equal to C. This is not equal to, not equal till we get to X. That's how it worked with the HashMap because we are sending the first character, So that's it. So with this, explaining this right, we look through the first element we have in the array. Then we put it in the HashMap. Now, once we look at these operations, we look at inserting into HashMap is O of 1. Inserting into array is O of n. So inserting into HashMap is O of 1. So every of this put function is going to run O of 1 time. But the loop itself is going to run, because we are looping through an array here, it's going to run in O of n. It's running as big as that array is. So this function here, we run in O of, let's say we are calling the first array A. Then we come to this next array. Of course, this one is running in O of 1. Then we come to this one, accessing elements in an array. Yeah, do we access? This is what is happening here. So that one is O of 1. HashMap.contains. So when we are searching through an HashMap, it's going to be O of 1. So this best case, I will show you where we can have the worst case O of n later. This is occurring in O of 1. Then of course this is a loop. This is not a loop. This is just each statement. So each of these statements are occurring. This one, printout, is occurring in O of 1, O of 1. This access here is O of 1, O of 1. So everything here is O of 1. But this loop itself is running in O of n. But since we are using two loops here, we are going to have this running O of b. So in this case, we are going to get the total, all this O of 1, O of 1, O of 1. There's no loop going on through here. This is the first loop. This is the second loop. Aside this, there's nothing like loops. This one that looks like a search is coming from the HashMap, and it's occurring in O of 1. So O of 1s are just negligible here. So we have O of A and O of B. So this will give this array, this function execution O of A plus B, which is better. It runs in lesser time than O of n squared. O of n squared. So we have this one running in O of n squared, this very function here, because everything here is O of 1, O of 1, but this guy is running in O of n, and this other guy is running in O of his own n. So it's going to be O of A times B, and O of A times B is also as fast or as slow as O of n squared. So looping through two arrays are like a terrible idea, right? But this is like the basic solution. It works, but it's not the optimized solution. Then this is the optimized solution running in O of A plus B, and this is of course way lower than something running in O of n squared or something running in, and this one is less than or equal to something running in O of A times B. It goes without saying. So let's remove this n squared first. O of A plus B is always going to be lesser than O of A times B. Say this is, except maybe A and B are 2, 1, 2. But we are looking at worst case scenario. If A is 3 and B is 2, A plus B will be 5. A times B will now be 6. 5 is less than 6. I don't know if you get the concept. So this, we are looping through the first array once. And once we are done looping through that, we just add it into the HashMap. It runs in O of A, which is O of n for that array. Then we are looping through the second array once too. But in this case, we are looping through the first array once, but we are looping through the second array each time we loop through the first array. So it's going to be O of A times B or O of B times A, or whatever the case may be. So this is like the optimized solution. And looking at this, you really can't really optimize this further. I mean, if you are going to look at optimizing this further, one thing we learned is that you are not struggling for a kind of optimization that is unrealistic. We are not doing science fiction optimization. If not, you are going to say you want to add this to what we have, a binary search tree, and have it run in O of log n, and log n is always lower than O of n, you know. But then we don't want that. We just want creating a binary search tree is you know, as crazy as it would be. But then we also have, wait, let me just go. Is there any questions? So I shouldn't be as though I'm talking.
Yeah. Sorry, I have a question.
Yes, please.
Sorry, please can you open that your code? I
Okay.
want to show you something. Sorry,
Okay.
yeah. Now,
Yeah.
I don't know if yesterday you actually explained how HashMap really works, because what I'm seeing here, the first HashMap, you use the HashMap.put, right? For the first one,
Yes.
to put it into the
Yes.
HashMap. So
Yeah.
the second one, I don't know what happened there, because I was
This
expecting you
right.
to still put it. Yes, I was expecting, like as the first one, I was expecting you to still put the second array like you did for the first one. So, but I saw contains keys. So is it that nothing happened there?
Yeah, this
Or is
is,
there?
yeah,
Okay.
like we are thinking through this solution.
Mm.
Before we even thought of it, I mean, it would have taken some time to think, okay, what data structure are we going to use to make it optimized? We want to loop through each array once. We don't want to loop through any array the number of times we are looping through the previous array. It won't make sense.
Okay.
So we have to
Okay.
introduce HashMap. So looping through the
Okay.
first array, you put everything in that first array inside the HashMap. I don't know
Okay.
if you get. So once you put
Okay.
it, you
Okay.
don't have to deal with this array anymore. I mean, I'm marking it here. See where the last time we used the array, we never used it here. So once
Okay.
we loop through this one, we are done. We put it inside the HashMap.
Okay.
Then we are coming here, we are looping through the second array. But this time we are looping through the second array. We are not testing for each element in the first array. We are now testing if the element we have at this array level is inside this HashMap. I don't know if you get.
Okay, this temp, that temp you created is the HashMap.
Okay, this temp is the character. It's just to make it more readable, right? More readable. I can
Okay.
as well carry this stuff, right, and put it here,
Okay.
and then it
Okay.
will look
Oh,
confusing. Yeah,
okay, I get
you get.
I get something now. Okay, that HashMap, that HSH is the
Yeah.
HashMap. So now
Yes,
you're
it's
not
the
saying
HashMap.
this particular variable, is it contained inside the
In
previous
that
HashMap
HashMap,
created?
yes. If it is contained,
Okay.
yeah, not true.
Okay.
So
Okay.
why? Yeah, thank you so much. So why is that faster? Because the time to search if something is inside an HashMap is O of 1. For the time to search
Okay.
if something is inside an array, you have to go through the array, you know, as long as the arrays. So we are using O of 1 in the term, in the replacing O of n. But since this is O of 1, this for loop is going to run in O of n, which is O of b, O of a, whatever, because we are using it. So the total will be, you add up everything which is O of a plus b, right? Of course, we can say this one is running, this if statement is running O of 1, this one is running O of 1, O of 1. Let's even do that, right? So that we spoke about that yesterday. This guy here is running O of 1, O of 1, O of 1, creating an HashMap is O of 1. This guy is O of 1, O of 1, this one is O of 1. So we have to have 1 plus 2 plus 3. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are going to have O of 12 plus O of B plus O of A. So we are going to have O of A plus B plus, 12. And like our rule states yesterday, the second rule, we are taking out 12, removing this constant here that we have here because it's inconsequential. I mean, if A is 1,000, I mean, you are just looking 12, you just have to remove it. So it will just be O of A plus B, right? So we are not counting all those constant time, anyone that is O of 1, right? Because it really doesn't matter. Like I said, yesterday document, we have where we are going to spend more time is when we are looping through arrays, and then when we are calling functions because of the stack. Of course, there's a different this thing called stack, but we are not getting into this yet. We are going to add more array questions to show why hash maps are important in handling arrays, because arrays are like a basic data structure. Every question you are going to receive are going to come in form of an array, give or take. Binary search tree will be an array with a formula. Queues, well, might not come with an array, but it will look as like an array. So you have to deal with arrays a lot. But then hash maps are ways where, you are searching in O of one, you are inserting in O of one. Like we say, this put function here, because hash map is in O of one, is going to put in O of one. If you want to delete anything in hash map, it's going to run in O of one. Now we are using Java here, right? I believe this contain function, if we are using JavaScript, right, it will go in something like HSH. You won't be putting something like contain. Then of course here too, if you are using JavaScript, you have HSH, HSH ARY, is equals to ARY. Different languages has their different way of implementing HashMap, but this is Java's way of implementing HashMap. Ooh, and the time is gone just for one question. Wow, I never knew we are taking so much time. But is there any question? Is everything understood? Is there any place we need to take? Yes.
Thank you very much. Like I really understood this concept you just taught now. So that means if I want to go, I write JavaScript. So when I want to go to JavaScript, I'll just check the implementation of HashMap.
Exactly.
To JavaScript, right?
Yeah, JavaScript.
Yeah.
The course I recommended was done in JavaScript. I learned in JavaScript, but I knew what he was talking about in HashMap. HashMap, they deal with objects. I think objects, JavaScript objects. I think that's what they do instead of HashMap. So, okay, no, not this one. Something like this. This is the key, this is the value. This is the key, this is the value. So see how JavaScript declared this hash map, right? This is like an hash map. What is it? Objects, they call it in JavaScript, right? So key value pair. But in Java, the way we implement it is different. Plenty boilerplate code. If I was going to do this in Kotlin, it would have been easier. But Kotlin, I don't think anybody should be using Kotlin to learn data structure and algorithm, because the inner operations of Kotlin use a lot of JavaScript function, and then it might not be how you think it is. Let me see if we have an array. Well, is there any other question before I go blabbing further? Any question, any place we need clarity? Hi, love it. Okay.
It's okay.
All right.
I think it's okay. We just have to go and check the implementation in our own language. Yeah.
Yes, in your own native language. But programming is like fundamentally almost the same everywhere. Yeah. So if you understand loops, there's a way loops are run. You can't really say, okay, I understand loop in Java, I don't understand loop in Python or this thing. They have different syntax, but it's almost the same thing. Gideon, you want to say something, please?
Yes. Hello. Good evening, everyone.
Yeah. Good evening.
Yes. Talking about my question has to do with the idea of the big O notation and all that. I don't know if I missed any part of it. Now, I was expecting that when you did the two solutions.
Yeah, I was going to check this.
Maybe there will be a command to check the optimize. Maybe a command to check the timing for that.
Okay.
Do we have anything like that?
Yes, there's a platform. Yeah, let me go even to this array. Yeah, let me see. I wish this should be on lead code. There's a platform. I was going to introduce lead code much later. Intersection of two strings array are equivalents. We are going to use more lead code a little bit later. I was going to introduce this here, but when I picked this question, I didn't quite check if this question is in lead code. But the next question we are going to be solving, I'm going to put it actually on LeetCode so that we see the differences. Now, LeetCode is a place where you throw your solution, it will see the time it will take. I mean, if I'm going to measure the time in these two functions, you are actually not going to see any difference. Why? Because we are dealing with these records, and let me just show you this so that you could see that. So we have this guy here, and you are really not going to, let me see, activity monitor here. So if we run this code, let me try and run it so that you see if there's any kind of pressure on the memory. Most of the times you won't see any pressure on the memory because systems these days are built fast, so everything is in the level which it's. So let's run. Nothing, no memory pressure, nothing. I mean, if we want to really test it and see the time it took to do this thing, I could find the code. Let me see. Find time taken for function to run Java. Maybe I could implement that. You know, maybe I could implement that. But I mean, I don't really want to do this right now because it's going to take in a different way of the course. But if you are really going to measure this solution we just built, you are going to actually find that the difference is not much. The arrays we are using are 3, but the elements in the array are 5 or so. You are not going to see the difference. It's going to be measured in way milliseconds. You can look through 1,000 records. Let me even say we have this function. Sorry, I am taking over time to explain this. So let's say for int I is equals to 0, I is less than 1, whatever this is. Okay, we can't use int there. Let's use long. I plus plus. So we're having an error here. Integer value 2i. Maybe we get it a bit. This is 1,000, 100 million. So let's system dot out dot print line I. Right. So let's comment all this other stuff we have here and run this our code, and let's see how fast we are going to get to. So once the code start running, see the number we just got to here. I mean, we are in over, we have gotten to 2 million already, 3 million. And this is less than how many seconds since we ran the code. I don't know if you get. So if we are going to measure this thing, this loop has run. We are not measuring this large record, right? But this loop has run up to maybe 2 million times in less than a second or so. And our loop, what we have here is not even up to 10 records. But I get your point, and we are going to use LeetCode to exercise. I to take that on me since I didn't search for the solution on LeetCode. I'm just trying to compress as much as we can in the class so that data structure and algorithm is a kind of exhaustive topic to start teaching because there are more than one data structure and algorithm to even face. There are more than 10 data structures, which you might not really get to on a daily basis. And then if we try to touch everything, we might take forever. I'm trying to take the important ones and give the ideas behind working on algorithm, behind optimization, and the most important data structures to look at when solving data structure and algorithm. We should have 2D arrays, graphs. As the class goes on, we might find out if we attend to that. But I mean, I promise this, the next time we are going to meet, we are going to run our solution on LeetCode. LeetCode is a place where to give you the time complexity and also the space complexity your code is using, so you know, oh, is it optimized or is not minimized. So thank you so much for that. Any other question? And does that answer your question? Of course, it doesn't answer the question. But
No, of course, I'm good. I'm good. Thank you.
Yeah.
I've used LeetCode, so
yeah,
and I know it has other functionalities. So it's just like an introduction. What you have said is just an introduction.
yeah,
So it's okay.
yeah. So
Thank you.
That's it. Thank you. So, any other question? Hola, can anyone hear me?
Yeah, we can hear you. We can hear you.
All right. So, I mean, in the absence of any other question, we are going to call it a day here. I mean, is 1 hour enough for these classes? A lot of us are quiet. I'm asking maybe user input. Yeah, Raphael, you want to say something?
Yeah, it's very okay for now because like everything you are
Yeah.
saying, I have to go back and go and review and all of that. So if it
Yeah,
gets, yeah, thank you very much.
Okay. Yeah. So we can also have this support system where you can ask questions. I think on Abuja Developer Circle, I attend to some data structure and algorithm questions as much as I could and ask a question. I mean, if you have questions, you can also post there. That also brings me to I know some of us in Abuja Developer Circle, I know some of us in Code Innovation. Then some I would apologize here. I really don't know how we got in contact. I know Anthony from Emmanuel, right? So you should also leverage on the developer circle. But we have a group, so you can ask me questions on the group. Yeah, Gideon is raising his hand.
Okay, I was just going to say, I don't know, because yes, the time is yes, we don't have to cover like the whole lot so that we don't get lost. But I don't know if it's possible that in the group, like a kind of what we're doing for the lesson is dropped so that we can like I don't know if that would be okay, like study before coming to class.
Okay, yes. Yes, that will be dropped. I worked on that this week and it was quite poor. I'm going to improve on that. This is the first time I'm taking any lesson online, and then I needed to see the reception of the people I'm taking it with and then test something. So I am, as it were, I'm treading on new waters right now, so I don't want to sink. Permit me for that. Yeah, but this subsequent class, I'm going to put the structures and send it ahead of time so that we can learn. Then we can come to the class and we can have a synergized understanding of what we are doing. That okay?
Yes, it's fine. Thank you.
All right. In the absence of that, I would say okay. Now for the next class, we should do some more research on HasMaps. I will send some links. Somebody dropped the link on our channel that is studying that data structure. I have not opened that course. I'm so sorry. Sunday has been busy for me. I just I'm staying in my church way, so I just came in and I have not had time to open that course and review and give you a feedback, but I will do that and let you know. So aside that, in the absence of any other thing, thank you all for coming once again. Lovia Duke, Godfrey Omeka, Gideon Sunday, Rafe Alemo Baja, Philip Obekpa, Olua to Blessed, and Anthony. I will learn how to pronounce his name more later. But Anthony, hi, please. Thank you all so much for coming. I hope you got some value in this, and we are hopefully going to talk more next week. But we'll communicate on the channel. Thank you so much. Okay, Blessed. All right, sorry about that. Thank you so much for reminding me. All right, so thank you so much. Have a nice day. Goodbye.
Thank you, sir. Goodbye.
Thank you.
Thank you. Bye.